Hello everyone, welcome to CSCAD Technologies. Today in this video we'll be seeing a model, a very simple model using sheet metal in CATIA as the CAD tool. Here firstly we need to understand the drawing as usual. As you can see, we have the front view, the right view and the top view. So in the front view they've specifically mentioned one thickness and the certain end-to-end dimensions of the flanges they have used or walls they have used. So the sheet is actually of one thickness and the overall size is 160 by 140, and there are two other walls which are added 190 by 60 and small walls over here for clamping purposes. Now, to begin we have to consider firstly our primary wall. A primary wall is usually the one which controls the complete sheet. So in that concept, understanding the base actually will be the primary wall for me. So let us begin making this very simple model using CATIA. Now, to enter into the sheet metal workbench in CATIA, you can go into Start Mechanical Design. You have Generative Sheet Metal Design and Sheet Metal Design. If you enter into sheet metal design, it will again ask you to shift the workbench to generative sheet metal design. So in the latest versions of CATIA, the generative sheet metal design is only widely used. So once you click on generative sheet metal design, as you can see on the screen, none of the options are usually highlighted. They are all deactivated because firstly we are supposed to define the sheet. Since we know the thickness, there is a parameter which we are supposed to enter, which is known as sheet metal parameters. So when you click on the sheet metal parameters, it will prompt you for the thickness and the bend radius. Bend radius calculation is usually a whole different thing, but right now I'm giving it equivalent to the radius. You can also give twice to the radius, there's no problem. Now, there are bend extremities and bend allowances. Bend allowances, the K factor is also auto-calculated as per the thickness of your sheet. Now, bend extremities is where we have to give reliefs to the model. For example, if I try to zoom in and show it to you, we have a relief over here. This is called a rectangular relief. So under bend extremities, wherever there is a wall which is created, which is added over here, there it requires a relief of this form. So let's try to give that relief over here. It's called a square relief or a rectangular relief. Now since it's in a rectangle form, I'll try to give a normal dimension staying 2 by 3 because there are no specific dimensions mentioned here. So I'll say okay. Now the relief is also given onto the parameter. To begin making this model, again as usual, you can see that everything gets auto highlighted. We can start with the base. So let's try to create a base by using either planar or by using your extrusion. The better option is by using the planar. So we can use the wall option to create the primary wall. There are two other options while creating this. The first one is actually when you want the thickness on one side or to the opposite side. The second one is exactly in the middle. In this one, the thickness is only towards one side. So I'm just trying to keep it at one side and start making my sketch. Getting to the top view and creating a simple rectangle. Now we know the dimensions of the rectangle, so let's try to give those. This one is 156 and this one is 140. Now, since we know the thickness, we can see that the sheet is automatically added. Now, the primary wall is actually called different in different softwares. It's actually called planar in Creo and wall in CATIA. Both are the same. Now, while making these models, there are two approaches which you can use, which is a bend approach and wall approach. Over here, I am using the wall approach. To know more about bend and wall approach, you can contact us for the training. In the advanced sheet metal, we'll be explaining you to use both the approaches. Now, You can use wall on the edge, which creates a wall. You can select the edge, it tries to start. Now, this is a standard shape. When I get into the right view, you can see that the shape does not match with the right view here. So that means that the shape of the wall is actually not a complete rectangle. We can actually change the shape by using sketch based design. Since the sketch is already selected, the edge is already selected, you can go to your profile and select the face. Now, you can start begin to making your sketch. You can just go into your isometric view if you're comfortable. We know where to start from. So you can just start from here and then go back to your normal view and then see how it works. This way, this way, and ends over there. I will coincide it onto the other side, and I'm closing the sketch. I will try to coincide on this side by using a coincide command on the edge. Now we know the angles and all the dimensions of the wall. So let's try to give that. We know that this is supposed to be 110, and we know this is supposed to be 60. We also know this is supposed to be 90. So once I exit, it tries to create the wall, as you can see. Now the sketch file we are making should be closed. It cannot be open, and you can see that the wall is actually created. Now in sheet metal, it is not advisable to mirror the walls because you naturally unfold the sheet and perform few operations. Or if you're using bend approach, the operations are first done and the sheet then gets bended. So before, if you use mirror and mirror operations like these for the walls specifically, then the flat pattern or the unbending operation will tend to fail. Now, I have a wall on the other side as well. I can pretty much use the same option like how we have done earlier, and then make a sketch and then select the face. This is my face. You can actually use the previous sketch itself, but I'll just try to use these two because I need the bottom face, and I'll use this bottom face, which is the full complete bottom, as the projection. Now I can join these two by simply using lines because we know the ends. Then pretty much do this. We can project the corners as well, but since there's a bend, the projection only will happen till here. It won't happen till the end. So that's why I took a line. Now you can see the wall. This is your actual wall. Now there are two more walls, as you can see over here, which is the overall distance is actually 45. So I'll simply use the wall approach again and then try to do it. This is a normal wall because since it's a rectangle wall, I don't have to take much effort to make a shape or anything. All I have to give is the overall length of the wall. Now, when I go into the right view, you can see that it auto takes the relief which we have already given earlier. Let me just try to say OK and show it to you. This is the relief. This is under the parameters. You can change the dimensions if you want. It can be 1 by 1 or 1 by 2 or anything as you're willing, you know, L1 and L2. Or you can also take it in the form of a square. You can keep it 1 by 1 as well. Now, similarly, there is another wall onto the other side. Let's try to take that too. Sorry. You can flip the direction. There's no issue. You can just say reverse position and give it. That's no problem. This is how you add walls using a wall command. Now there are few holes given in the on the wall for clamping purposes. So let's try to give those as well. I'm just using a hole command. Okay, let me select the face first and then select the hole command. It begins. I have to give the dimensions as per this. I'm just trying to use my constraining part to do so. From the edge it's actually 22.5 and from the top edge it's actually 10. No, the dimension of the hole is 6 and it's up to the next. We can create a pattern for. No, under insert, we do have transformation which has pattern over here. It's not in the toolbars over there. So under rectangular pattern, I can just select what is that I'd like to pattern and then select the direction, as in which direction I'd like to create a pattern and how many copies do I want. I want 3 copies with a spacing of 15 as shown. So I'll just try to give 15. Oh, it's over here. The transformation tab is over here. Okay, I'm so sorry. And say, okay, since I want it only in one direction, I'm trying to use the first direction only. This whole thing can be mirrored onto the other side. Again, I have transformation mirror with respect to the center. You can see the mirror operations of the clamps. Now you can give rounds as well using a round command, which is called a corner in this. You have to just select the edges of the wall and give the round. This is the first edge. As you can see, the round is actually R5. So I'm just trying to keep maximize this, as you can see again. I'll just change it to R5 and then select the edge. Let me select the edges first. This as well as the last edges are to the other side. This all is about 5. This is how you give rounds in your CATIA. Now there is also a center hole which I actually forgot, which we are supposed to do before itself. I'm just doing it now because I have forgotten the center part. I'm so sorry about that. Since it's exactly located at 0, 0, it's exactly located at the center. Let's try to coincide this at the center and coincide this at the center as well. And exit. The dimension is supposed to be 80 up to next. This is your complete model of your sheet metal. It's a very simple sheet metal component, not even a complicated one. We have also not used any sort of punching or forming operations on the sheet. It's a basic level of your sheet metal training for your practice. Once you have understood all the walls and everything, we can go into the a little more detailed drawings of sheet metal and how to understand them. Meanwhile, if you're looking for any advanced level of training in sheet metal in CAD software or mechanical CAD software, we can definitely help you out. We do have openings also for SolidWorks and CATIA sheet metal. You can contact us and our details are given in the description below. Thank you.